Welcome to Crystal Clear Chemistry channel. In order to crack either JEE mains or NEET exams, let's strengthen our basics of chemistry through this channel. And in this video, I'm going to discuss the part 5 of IUPAC nomenclature, that is about benzene substituted compounds and all, alicyclic compounds and all. And for the previous concepts, please go through the playlist. Definitely this video will be very helpful for you to strengthen your basic, not only the basics but also the grand test and important questions and the replica questions of JEE mains of different concepts have already uploaded in this channel. So please subscribe to my channel, and if you really like the video, please share to your friends. Okay, thanks for watching. Without any delay, let's get into the topic now. Rules for naming the aliphatic compounds having polyfunctional groups. A compound is said to be a polyfunctional group if it contains more than one functional group, right? The multiple bond or triple bond is also considered as a functional group. In IUPAC system, one of the functional group is chosen as a principal functional group. The remaining functional groups, we write it as a secondary functional group as substituents, right? We know already whenever there are two functional groups, first one we need to take it as a main functional group as a secondary suffix, and the secondary functional group we need to write it as a substituent. And don't forget that the double bond and triple bonds are also considered as functional groups here. Now, for example, if we consider the compound with COOH and the OH, as both are functional group, this is the principal functional group because it comes first in the order, and whereas the OH is taken as a substituent. Now, first step in naming the polyfunctional compounds is the selection of principal functional group. The principal functional group gives the class name of the structure. Okay, class name in the sense whether they are alcohols or carboxylic acids, like that it mention the type of the compound also. The second step is the selection of parent chain. Parent chain is so selected, it includes the maximum number of functional groups including the principal group. Definitely whenever there is a chance of including the all the functional groups, we need to try our best to select the parent chain. And the third step is numbering. The parent chain is numbered so as the main functional group must get the lowest number. See, for example, if we consider this one, let's try to give the number for this type of compound and try to comment below. Give your answer in the comment section. I will respond. For this also, for cyanide group, what type of number you can write? Comment below. And here there are two double bonds are there. So what are the numbers for the carbons with triple bond? And here comes when there are more than two, how to write, and what is the OH carbon, what is the number of the carbon with OH, please mention below. And the same case here, the halogens, whatever the halogens are there, whenever two halogens are there, we need to definitely follow the alphabetical order if they are at similar positions. Now listen carefully. Suppose if we consider the IUPAC nomenclature of alicyclic compound. Cycloalkanes are alkanes in which the carbon atoms are arranged in the ring form. Hence prefix cyclo is added. So as there are 5 carbon atoms here, they must be included, and hence it is a pentane, and as it is a cyclic compound, the primary prefix cyclo must be included. Suppose if we consider this one, when the ring chain contains more or equal number of carbon atoms, than the alkyl group attached to it, then it is named as a derivative of cycloalkane. See, suppose if we consider Here there are 4 carbon atoms in the cyclic compound and there are 3 carbon atoms in the side chain. That's why this is the main compound and this is taken as a substituent. Hence the name of the compound is propyl cyclobutane. In case of alkane chain containing more number of carbon atoms than the present in the ring, then a compound is considered as the derivative of the alkane. See, suppose if we consider this particular thing, um, here there is a, yes, here if we consider this one, there are 3 carbon atoms in the cyclic compound and 4 carbon atoms in the chain. So, you have to take the chain as the main compound and the propyl group, cyclopropyl as the branch chain, and hence 2-cyclopropyl butane is the name of this compound. Similarly, if we consider the cycloalkanes and cycloalkynes, you can clearly see here the word cyclo must be included, cyclohexene, cyclopentane. In the case of substituted cycloalkenes and cycloalkynes, double bond or triple bond must be done as 1 and 2. So, in the direction is chosen to find the lowest number for the substituent. See, for example, if we consider this one, double bond gets first priority. So, 1, 2, 3. Okay, 1, 2, 3. And the third carbon atom methyl group is there. So, 3 methyl cyclohexene. Similarly, if we consider this one, as both must include in the continuous number, you start from here 1, 2, 3. So, this time this is 3 ethyl cyclopentane. Okay, now suppose if we consider the nomenclature of the substituted com benzene compounds, you can check here. The root word for benzene derivative is benzene, and the name of the monosubstituted benzene compounds are usually derived from by preferring the name of the substituent before the word benzene. For example, if we consider on benzene, if NH2 is there, it is called aminobenzene, which is also called aniline. If benzene contains OH group, it is called hydroxybenzene, which is also called phenol. If the benzene contains CHO, it is called formylbenzene, which is called benzaldehyde. If the benzene contains COOH, it is called carboxybenzene, which is called benzoic acid, and you can clearly see the name of the structure of the benzene sulfonic acid here. Okay, now substituted aliphatic compounds, especially the substituted aliphatic compounds, if we consider, see, benzene with CH2COOH, already benzene must be there, and substitute if the alkyl group is substituted with the functional groups like CH2COOH. See, for example, if we consider this particular thing, COOH CH2, so first priority 1, 2. On the second carbon, this C6H5 taken as a phenyl, so 2 phenyl ethanoic acid. Okay, similarly, one, this is first carbon, 1 comma 1 dichloro phenyl methane, because only one carbon is there, so you can take this as a methane. This is also called benzyl chloride. Benzyl chloride. Substituted aromatic compounds, if we consider when two similar substituents are attached to the benzene ring, the relative position of the substituents must be indicated by adding the symbols ortho for 1 comma 2, that is O, meta for 1 comma 3, that is for M, and for P, para, it is 1 comma 4 before prefix. What does it mean? Suppose if we consider these compounds in which the two methyl groups are on side by side on the benzene, this is called 1, this is 2. Whenever they are side by side, we can say it is they are the ortho positions. They are occupying the ortho position to one another, relative positions. Ortho 1 comma 3 called meta, and 1 comma 4 positions are called para positions, which are relative positions. And here you can clearly see that this 1 comma 3 dinitrobenzene is called metadinitrobenzene, whereas hydroquinone, if we consider on benzene, if two OH groups are there, it is called hydroquinone, which is also called parahydroxybenzene. Okay, now if two substituents are different, then the compound has no special name on account of any of the substituents. The two substituents must be named successfully in the alphabetical order, and the name ends with the suffix benzene. For example, bromo-chloro, two different substituents. Bromo comes first, hence the numbering also start from there. Hence 1 bromo 2 chlorobenzene is the IUPAC name of this particular compound. This is called orthobromo-chlorobenzene, right? Now, see, suppose if one of the two groups is such that that gives a special name to the molecule, then the compound is named as a derivative of it. For example, if we consider special name, on benzene already NH2 is there, the special name is aniline. Then we have to take this chlorine as a substituent, and you have to write, start numbering from that special substituent NH2, and here it is 1 2 3 4. On the fourth carbon atom chloro is there, so 4 chloroaniline, it is also called para aniline. Similarly, this is called 3 nitrophenol. Okay, whenever the special names are there, the other groups must be considered as the substituents. The positions of the substituents, tri or polysubstituted benzene derivatives, are generally given by suitable numerical prefixes. For example, if we consider this one, if we consider this one, this is called 1 comma 2 comma trimethyl benzene. This is 135 trimethyl benzene. This is 135 trihydroxybenzene. This is called fluoroglucinol. This is called mesitylene. Okay, if one of the groups is such that it gives special name to it, we have to take it as their derivative, and we have to give the position also 1. The order of seniority of substituent groups you can clearly see, just like that of the functional group order. COOH, SO3H, CN, CHO, COOH, NH2, R, NO2 and X. Okay. COOH, SO3H, CN, CHO, COOH, NH2, R, NO2 and then X. See, you will clearly see COOH gets first priority. Amino group, from there if you write this is 1, 2, 3, 4, 5, clearly you can see the examples here. And these are all the some of the common names of aromatic compounds, which you need to study on your own, self-learning aromatic compounds: orthocresol, paratolidine, acetophenone, salicylaldehyde, anthralinic acid, salicylic acid, phthalic acid, etc. All these are the common names of the some of the famous compounds. Next, the common name of the few more aromatic compounds: sulfonilic acid, acetanilide, saccharin, cinnamic acid, vanillin, pyrogallol. See, we have seen already fluoroglucinol, where the OH groups are alternatively located. But here, if we consider all the three OH groups are side by side, it is called pyrogallol. And sulfonilic acid is nothing but NH2 and SO3H here. And cinnamic acid, saccharin. Saccharin is nothing but COSO2NH. On the benzene, COSO2, which are connected by the NH group. Okay, so these must be noted down and these must be learned for you solving some of the important bits. Okay, and here also you can check anthronylic acid means NH2COOH. If OH side by side salicylic, if two COH groups are side by side phthalic acid, COCH3 is there, acetophenone. Toluidine means CH3 and H2. Cresols means one CH3 and one OH will be there. Salicylaldehyde. Anthronylic acid means NH2 and COOH. Okay, so that is all about the part 5. With this, the nomenclature videos got over. Please check the playlist for the remaining rules. Okay, thanks one and all.